Minya, hello nya, I'm Virtual Neko, Neko Mia Sebastian this nya. I started working on a new project. I wanted to show it off. So I don't know if you guys have seen this thing. I don't know if it was like a Twitter or YouTube, but being in my algorithm, it was like, oh, if they made this game in the past without graphics cards, acceleration, and like you could do 3D, and like nowadays you have stronger processors, you could do it just, and it's like portable, and like I don't know. Anyway, it seemed interesting. And in my mind, what I thought is like, oh, like 3D is annoying to work with because the like engines, right? Like Unity sucks, right? Like I know I use it, but I don't like it, and like no, it's fine. But like anyway, you know, things like OpenGL or whatever, they're like a pain to use. And so I'm like, what if I could roll my own system? I can make it how I want, add the systems. I'm gonna like understand the inner workings of it. I thought that would be cool. So anyway, here's what I have so far. This is running in the browser. I thought that's very, very cool. You have this cube, you can move it around, whoa, and rotate, whoa, and add more, whoa. So anyway, that is my project. That's it. See you later. No, I wanted to show off the code I'm doing for this, for documentation or something, I don't know. And I wanted to show off the, or maybe just talk about my future plans for it. I don't know. Do it in style of NekoQuest devlogs, because I think those were fun. Okay. So, oh, to start out, yeah, so this is using, this building off the engine I worked on, but never finished the game for. This game, the Whee! Neko's Bounce. Yes, they do. Let's see if I can get it. Oh, nice. Anyway, this game, I made a system where there's a camera. So instead of, you see these like black things at the edge, this is the whole canvas. This black part even is the canvas. We're just filling it in. And so we have this camera system that lets you move and draw stuff like offset. It doesn't work well for tiles because you see these little lines in the middle. But like for 3D, like look, like we got 3D situation going on. Like how cool, right? Yeah, so this is where it started because I'm like, oh, well, if I'm already drawing, you know, normally you draw from upper left to right, top to bottom. This is the center, essentially, 0, and this is like max. Which is a problem for 3D because it's like weird. But anyway, this system, this is now the center. It's like -1, 1, -1, 1. And you have to do math in like 2D, but in 3D it makes sense because it's like it's this 3D space. It's like how it's meant to be done. Does that make sense? I don't know. Anyway, so I built off that. I just copy and pasted the entire code base from that previous project. Maybe someday it'll actually, you know, I'll finish that project. I don't know. Who knows? So let's start. Oh yeah, this is NekoCam. This is from the other project. This is what I'm talking about. That the other project makes all this like stuff, all this, I don't know, camera offset, 2D cool stuff work. Let's see. Okay, so we have all this math. I don't know if we need to go through all this. Half of the screen size, and so we can offset. When we resize the screen, we update all the stuff. So, and the main point of this is because I made Worm Game, right? I'm like, oh, I'll make it so it can be run on the phone. It's gonna be so cool. And then it didn't run on the phone, or it did, but it didn't run when I put it on Itch. It didn't run on the phone. I'm like, why? Because the scaling, and Itch messes up the scaling when the actual original, like if you run it in the browser, it doesn't mess up the scaling. I don't know how that happens. Anyway, so basically what this does, let's see, there's math somewhere here, math. And this thing does math. So we multiply by the screen size. So we're turning pixels essentially into 0 to 1 or -1 to 1. Like we're turning pixel scale, which is like, if we go back into our web here, it's like 1 pixel, 2 pixel, 3 pixel, 4, 5, 6, 7, 8, or however many, I don't know, I'm not going to count them all for you. Like however many pixels by however many. Normally I have to say, oh, the cat is drawn 50 by 200 pixels in the screen. When you move him, he moves in that space. Oh, so what this math does is it scales the pixels to the -1 to 1, to the 1 to -1, whatever, space. And that's advantageous for 3D because again, you have these cube things here. So, yeah, the scale I think is how we get the screen scale. And here's 1 because we're not using that system, but before, you had the pixel size. That determines the camera size. So this is like the resolution. So like 9 by 5 hours that you go to work for. And it scales the screen out. But then it's weird for 3D because look what happens when you go to the edge. It scales. I have no idea why this happens like mathematically. It's actually insane to me. how they're like fine in the center and then you move to the edge and they're weird. Like look, like this is this shape, but when you move it to the edge, look how it like scales, right? It's crazy. So anyway, we change it back and well, this is just meant to be that way. And if you move to the edge, it properly scales. That's the point. But in the other game, you want like a screen resolution, because if you're on a phone, it'll scale this size and it fills up the screen. It's all beautiful. And then again, the pixel size. So there's like how many pixels per one screen unit. So the other game, I think it's like 7x3 or something, or 3x7 maybe. And then the pixel size is like 24. So each tile is 24 big. There's 3 tiles by 5 tiles. But then you can scale the tiles. You can zoom in and out. So that's what this draw functions do. They draw them bigger based on like the screen scale, and then the screen scale updates based on how big the screen is. So if you scale down to like a phone, or if you just resize the browser window, it moves with it, it updates, everything is good. That's the old system, because we don't care about all this. What we do care about is draw polygons. So this is now we're getting into the new, this is what we started working on for our new 3D project. So let's see what we got. So we're just getting the context, raw context, graphics context, and then we draw polygons. So we can draw polygons, which is like my biggest concern. I thought I was gonna have to like homebrew this, but luckily the canvas just does it for us. We don't even have to draw triangle and triangle. We can just draw any polygon we want with this awesome code here, and like closed path and stuff. We can draw lines. So like if we go in here and we want to draw lines instead of models, we get line view. Wireframe, what's it called? Something like that. Yeah, so we have lots of flexibility here. Where were we? Yeah, that's pretty much the only new thing here at all in any amount. And camera position is 0. So this doesn't matter. And I think I'm going to use a different camera position, but we'll get to that later. So everything else is like kind of extracted out. I'm going to try to go through this in the order that I kind of made it, but we'll see how it goes. So this is the neck of 3D drawer. So this was originally all in main in like draw function, but it was chaos because it was like 200 lines long. It's like, that's psychotic. So I extracted them out just recently. I made the thing yesterday and it was late yesterday, semi-recently. It's tomorrow morning today, or I guess it's today morning. So with that day math out of the way, so this is what you do with this. You queue a model for drawing. Because the problem I ran into, right, is if you have this like cubes, right? Say you have a cube here, and you have a cube here, and you have another one. How do you know when one is supposed to draw in front or behind of a different cube? Like, you draw them in the order, but what if you like move behind, and then what if it's like half angled? Like, and my system doesn't work perfectly, by the way, and I'm leaving it. It's scuffed intentionally. I mean, if it was easy to fix it, I would, but it's not, so it's semi-intentional. Anyway, so this is what you essentially do for like the pseudo draw function. So in main, you get all the cubes in the scene, you queue them up, then the drawer does stuff with them. And then after, so it does the draw, it draws all the cubes, and then it clears the queued models for like next frame. This is just the easiest way I found to do it. So how do we draw the models? This was like not the bread and butter, this was like the pièce de résistance or something. It was like the big, I gotta solve this to make this anything here work. And what is that thing? So we have the model. We'll look in the model in a second. It's pretty simple. Again, that's extracted. This was the whole model. All this was like in the draw function. Again, psychotic. So we get our queued model. So when a model says, I want you to draw me, drawer is like, okay. We get the transformed point. So the model starts out its life being an unrotated, unpositioned cube. And it doesn't really look very interesting. So you like, oh, you can move it. Well, moving is a transformation, I guess, and you can rotate it, and you can scale it also, but there's no buttons for that, but you can technically do it. This gets the transformed points of the model, so the model doesn't change itself. You transform on the fly, and there's advantages to that, I think. And then we get the faces of the model. So the way my models work, I guess we'll just look at the model, we'll go back and forth, it's fine. A model is a shape. These are the points, so these are like the corners of the cube. Faces, these define which points of the shape to use for each side of the cube. And you have colors, which colors each side of the cube. Position, rotation. This is just the same as rotation, just a different form. Scale we're not using, but it how big it is. Cached of the scaled and like rotated and stuff, the points goes in here. We invalidate them when we like try to change it. I guess I don't need to do that. Oh no, I do. Anyway. So this, we regenerate the points if we need to, because if the model doesn't move, we don't need to regenerate them. We save a huge amount of computation. And especially with rotation, because this is like math heavy. Like, look, like, let's see, where is 3D, Mat 3? 3D Matrix. It's not well done. It's not my best work. I know you could use an array. I'm sorry. This was most of the time. I was like in Paint, like, okay, the matrix multiplication, like X goes here and Y goes here. This is matrix on a vector, this is easy. This is matrix on another matrix. And this is a lot of math. This is probably like expensive or something. I don't know. I guess these are expensive as well. I don't know. Anyway. So we only recalculate this when we need to, but we store it otherwise. We're getting lost in the weeds. Let's pull it out. So, we clear out the points if we want to add new ones. Go through every point in the shape and then add the points. We scale them. Oh yeah, you scale, then rotate, then translate. If you do it in the wrong order, they get all fricked up. I don't know why. It's not like transitive or commutative, or I don't know what's the math term. I'm not good at math. That's the bottom line. So you have to do it in this order. If there's other things, you probably have to figure out the order that they go into. I don't know. Don't ask me about it. Or do. That's fine. You can do whatever you want. You get an individual point, and then get the faces, which return these, which we need to like get a reference back to the parent and like the index, and there's stuff, and I want to redo this later, but it's, you know, good good luck. Okay. And so then what we do is, instead of sorting per cube, because originally what I did, I sorted per cube to see which one is in front, which one is behind. But like, what if you have a cube that's like this? Frick, it's all rotating weirdly. Like, oh, that's a small one. Like this. I know the drawing is scuffed, don't worry about it. You want it to draw in front or behind based on the faces, right? On the edges, not based on the cube position itself. Because here it's like technically behind, but we still want to draw these because they're jutting out. If you see this little piece is like jutting out of this thing here, we still want to draw it. And how do we do that? We got to do per face sorting, not per model, like position sorting, which is what I initially wanted to do, and it would have been easier, but I can't, so I won't. Here's the sorting. So we take, I don't know if this is still right. We're using position to the camera, yeah. Translated point, yeah. So I may have to get Paint out to actually like diagram this. Let me explain it first, and then we'll see if a diagram is like warranted, right? Okay, so what we're doing here is like a sorting into a new array. We want it in the new array for, I think, reasons, because normally sort in place, but I don't think we want to do that here because these are, I don't know. Don't mess up my code, me from the future, from the past, me's code. Okay, so we sort maximum dist. So I think we go from highest to lowest. So the ones that are highest distance away from the camera get distance squared. It doesn't matter if it's squared because they're all squared, so it essentially cancels out. And the reason we take squared distance is because it is more efficient. Yeah, we take the point. Yeah, the point of each. Oh, we're taking each point of the face, and then we take the maximum point distance. So we sort highest to lowest. So the highest distance gets drawn first. And then the things that are closer to you get drawn over the top of it. It's like painting a picture. You draw the background, then you draw the little trees, your mountains, your happy little trees, right? Then you draw your, I don't know, character, your house or whatever in front. It's just like that. It's the same as in 2D, super easy, probably very inefficient and the wrong way to do it. I don't care. I'm doing it myself and it's fun. Yeah, 3D stuff. Okay. Then, yeah, we insert, if it's higher distance, we insert before. So it'll be like, if it's, you know, a 1, and then the next one's a 2, it goes before it. If it's a 3, it'll go after the 2 and before the 4, you know what I mean? But they're not all they're gonna be like 0.1, 3, 5, 7, 6, 2, 3, 4. It's gonna be a crazy number. And we have 2 arrays just because easier. I don't want to make a new data type for this freaking sorting. I don't know. Easy logging. This is where the drawing happens. We take the face, and this face, if you remember, is this. The reason why we need this is because we need the face. Okay, so the face data is the, let's see if we can get a, yeah, is this. So the face data is each face, so this is like the front of the cube, the left of the cube, the top of the cube, right? Oh, it says right here what they are. Well, ignore me, these are correct. What I said is wrong. These are just random points, you have to put them together where they need to go. That's what the faces do, so it gets 0.0, so the top face is 0, bottom, back, right. So this is not the top face at all. I don't know how I messed up this math. It's with minus height, I guess the minus height and the plus height. I messed it up, you know, don't worry about it. It works is what matters. Don't question it. I mean, do question it, you should, it's good to, okay, whatever, anyway. So it takes this point is probably like the upper right, I probably labeled them wrong. 1 is probably the upper left, 3 is the, yeah, top back right, so these are probably correct. And these are probably switched in the labeling, but they work. And then 2 is the top back left. So it's taking, you know what, we need to get the paint window out because this is better described elsewise. So you got your cube, right? I did many of these diagrams yesterday trying to figure this out, so you get to enjoy them as well. Of course, drawing a cube is somewhat challenging for some reason. And you gotta draw the back because there's stuff behind there that's occluded behind itself. And then you go there. And so you have these like points, right? Can I zoom in any more than this? That's the best we're gonna get. I apologize. No, I don't. We got our points. I was like behind. We got our, what is it? 8 points, something like that. And so the way this works is each point is labeled. 1, 2, 3, 4, 5, 6, 7, 8. Something like that. So you want to get a face, right? You go 1, 2, 3, 4. This is now your polygon that you're going to fill in for a face. So that's how they work, I guess. We'll use paint in a second, so I'll leave it up. It wasn't for naught. So that's what these faces are. It's the index of these points on the cube that it's using to draw the polygons. And the color array, this is just random colors for now, but you can use your own colors for like an actual cool model to like color it and stuff. I don't know. And then maybe we'll have shading eventually. I don't know. That might be insanely hard to do. I'll figure it out. So anyway, this face is this data type. It has these indices of like the points that we want for each individual face. And so this is like one face, two faces. It's an array of arrays, a list of lists. And then we have a reference to the model because we need it to get from the face. We need to get the index of like the point. And then we have the index of ourself, of which into this, so we're face 0, face 4. That's used because the colors and the faces are the same like array. And I don't want to store each of that in the face because it's the same color and like many guys may reuse it. So it's good to have it referenced instead of just copy it every time. And then this is like, again, this is the part, this is the math, which is actually easier than I thought. So you get the array of points for the polygon. We're looping through each index of the face. So it's like index 0, 1, 2, 3 of the cube. Remember our cube? This is our 0, 1, 2, 3. That's these. It's these guys. That's what we're pointing to. We get that point. We already translated them earlier. We're just getting it based on the index of the face because we had to translate the points, sort them. Now we're drawing them. Now that they're sorted based on like triangle position or whichever. And then if z is greater than 0, we need this because if it's not, then it draws behind the camera, which is not what you want because you can't see things that are behind the camera because it doesn't see them. That's how cameras work. And then we add the points. Point.project. Let us go into vec3 to see how it works. It's very easy. Crazily enough, we just take x divided by the z and y divided by the z, and it turns the 3D coordinates into screen coordinates. It's actually magic. I don't know how it works, but it works. And so I won't show you the math because it is, I don't know how it works. I just selected everything in OBS, not in Paint. So we'll keep this square just for like moral support here. So let's just do on like 2D here. If the camera is like this, here's your like little camera. That's a camera, like an old filmy camera looking like this. Here's the point. at which it's like looking on the screen. You have a cube here. You draw it, right? It like projects or whatever, divide by Z. It's math. I'm not here for the explanations, I'm here for the cool stuff. And I don't know the math, so I'm sorry. Okay, but what's happening is the cube's like here. This is Z equals 0 is here, or 1, maybe. It's one of those numbers, I don't know, something. Is this line here. So if you're behind this, you don't want to draw because the math freaks out. And it draws it like bigger, and it was drawing like, whoa, like it was going behind the camera. Okay, and then we draw the polygon. Then this model we already kind of explained. I think that's everything. So here's my plans for the future. A 3D editor thing. I think would be cool to make models, to make worlds. We export them in a custom format to load back in to this like engine thing. Here's my ideas for it. We can make an animation system to like make little guys like attacking each other, or like, I don't know, spaceships moving or something cool. This is crazy. I don't think I'll ever do this, but it's an idea. Like chiptune music editor or something. I want to make so here's my overall plan. This may never come to pass, but with this cool little project, I want to make a sort of like engine. Like a game engine, I guess, in the browser. So you can make 3D games in the browser, and it's like custom built. You know, you're not using WebGL, you're not using Unity with all their craziness. It's your own stuff. You get your own craziness. It's perfect. It's awesome. So that is my project. I'll try to keep updating because it's freaking cool. That is if I work on it. Hopefully I will. I want to keep working on stuff and making progress. So that is what we got. Thank you for checking out my silly little project, and hopefully I'll see you in the next one. Bye, nya!